All right, let's dive into this. Heritable polygenic editing, HPE. You guys send us some really interesting stuff on this, and we are ready to unpack it.
It's definitely a hot topic, yeah. Both for scientists and just like the general public.
For sure. I mean, we're talking about editing multiple genes in embryos and like reducing disease risk, but like forever, for generations. It's kind of wild.
It is pretty wild, yeah.
So we've got a couple of sources today. One is this newsletter from Titus, who, and I think this is super interesting. He's got experience with Colossal Biosciences, the company that's trying to bring back the woolly mammoth.
Yeah, Colossal is doing some really cutting-edge work in genomics. HPE is definitely on their radar.
Which is kind of crazy. And then we've also got this paper from Nature.
Oh yeah, the Heritable polygenic editing. The next frontier in genomic medicine paper. That's a good one.
Just the title, gives me chills. Okay, so before we get too deep into this, can we just, level set? So I think of single gene editing, which we've heard a lot about, as, fixing a typo in a sentence. And HPE is, rewriting whole paragraphs, making the information clearer, more impactful, but for, generations to come.
I like that. That's a really good analogy. It really highlights the difference between single gene editing, which focuses on correcting or replacing one single gene that causes a disease. But a lot of common diseases, heart disease, Alzheimer's, diabetes, those are influenced by a bunch of different genes, not just one.
Totally. So that's where HPE comes in, right?
Yeah.
We're talking about targeting multiple genes at the same time to really impact these complex diseases.
Yeah, and what's really interesting is that we've moved beyond the theoretical. Titus, in his newsletter, pointed out that the whole conversation has shifted from if we can do this polygenic editing to how.
So it's not just a sci-fi fantasy anymore.
Not at all. Scientists are working on techniques to edit multiple genes at once. They call it multiplex editing. And, places like Colossal Biosciences are right there on the front lines, working on this, using these techniques for all sorts of things, HPE included.
See, that's where things get really interesting. Because if they can actually edit multiple genes, we're talking about potentially rewriting the genetic predisposition for some really serious diseases.
And the Nature paper, they actually give some specific examples of just how powerful this could be. For example, they estimate that if you could edit just 10 locations in your DNA that are associated with coronary artery disease, you could theoretically reduce the lifetime risk from 6% to 0.1%.
4.1%. That's insane. Are they talking about similar possibilities for other diseases?
Oh, yeah. The numbers are pretty striking across the board. So for Alzheimer's disease, they estimate that editing 10 genetic variants could take the lifetime risk from 5% to under 0.6%.
So someone who might have been, predisposed to developing Alzheimer's could potentially avoid that.
Potentially, yeah. And for schizophrenia, it's even more dramatic. They suggest that editing 10 genetic variants could bring the lifetime risk down from 1% to just, again, 0.1%.
These numbers are crazy, but I can't help but think, okay, but the ethical implications of something this powerful, I mean, we're talking about messing with, the human germline, changes that would be passed down for, ever.
Yeah, for sure. The ethics are huge, and it's interesting that both of our sources, Titus in his newsletter and the authors of the Nature paper, they both bring up this case from 2018. This Chinese scientist, He Jiankui, it was really controversial.
I vaguely remember that. What happened again?
Okay, so He Jiankui, he used CRISPR, and he edited the CCR5 gene in human embryos.
Yeah.
His goal was to make them resistant to HIV.
Wow.
But the thing is, the scientific community was, outraged. Mostly because he hadn't followed the rules, the protocols, and he didn't have, the necessary approvals.
Sounds like he crossed some serious lines.
Yeah, totally. But you know what? In a weird way, it might have been a good thing because it sparked this massive global debate about gene editing, especially, the ethics of heritable changes.
So kind of a wake-up call for the whole field.
Exactly. And both Titus and the Nature authors talk about how the He Jiankui case really forced everyone to think about the ethics, and it led to, more research on safety, making it more precise, and coming up with ethical guidelines.
So a silver lining, maybe.
Mm-hmm.
So now that we know that ethics are front and center, let's talk about some of the challenges specific to HPE.
Yeah.
I mean, editing multiple genes, especially in embryos, there's got to be risks, right?
Oh, absolutely. And the Nature paper, they lay out a bunch of ethical concerns. One of the biggest is safety and precision. We're talking about editing a bunch of genes at once. And, there's always the risk of unintended edits, what we call off-target effects.
Off-target effects. Can you explain that a little more?
So imagine you're trying to edit a specific word in, like a document, right? But then you accidentally change a similar-looking word somewhere else in the text. That's kind of what can happen with gene editing. You're trying to target a specific gene, but the tools, they might accidentally change other parts of the genome.
I see. And those accidental changes could be bad.
Potentially. And it's even scarier with these heritable changes because those unintended edits could be passed down, like, forever, and we don't even know what could happen.
The more edits you make, the higher the chances of something going wrong. I get it.
Right. And that's why research is so important, to minimize those risks. They're working on making gene editing more precise, more predictable. But we're not there yet. We can't guarantee that HPE will be completely safe, especially when we're doing multiple edits.
It's a lot to consider. It feels like we're still in the early stages of figuring all this out.
Yeah, that's fair. But the progress in, related fields like somatic gene editing, where they're editing genes in non-reproductive cells, that's actually pretty encouraging.
So there's hope that we can make this safe and effective. But even if we can, what about the cost? This kind of technology has got to be super expensive, right? At least at first.
Yeah, you're right. Early HPE technologies are going to be very expensive. And that raises some serious concerns about equity. What if only rich people can afford to edit disease risk out of their genes? It could create like a whole new level of health disparity.
So it's like a world where rich people can literally buy better health for their kids and their grandkids while everyone else is stuck with the same risks.
Yeah, exactly. And we already have so much health disparity. This could make it so much worse.
It's a disturbing thought. So what can we do to prevent that?
It's going to take a lot of work. We need to keep investing in research to make HPE safer, better, and cheaper. As it gets more advanced, the costs should come down, like we've seen with other medical technologies. But that's not enough.
We need to make sure everyone has access, right? Not just the wealthy.
Yeah, absolutely. We need to think about policies and regulations that make sure HPE is accessible to everyone. Maybe government subsidies or insurance coverage, something to make it available to people who can't afford it on their own.
It sounds like a massive undertaking, both scientifically and societally.
Yeah, for sure. And, we haven't even touched on some of the really tough ethical questions, like where's the line between preventing disease and, like, enhancement? If we can edit genes to prevent disease, what's stopping us from using the same technology to make people smarter or more athletic?
Those are some deep questions, and it feels like this is just the beginning of the conversation.
It is, but it's a conversation we need to have, and we need to be smart about it. We need to really think about the consequences, all of them.
Well, on that note, maybe we should take a break and come back to this. There's a lot to unpack here.
Sounds good to me. All right, so let's pick up where we left off. Remember those statistics about reducing disease risk?
Yeah, those are pretty mind-blowing.
The Nature paper, they actually did some modeling to estimate how editing specific genetic variants could change, like your lifetime risk for certain diseases. And what's cool is that they looked at the potential impact of editing even just a small number of genes.
Okay, so remind me, what was the deal with coronary artery disease? Like, how much could we reduce the risk?
So for coronary artery disease, they found that editing 10 genetic loci, those are just specific spots on your DNA, they could theoretically reduce your risk from 6% to, wait for it, 0.1%. That's huge.
Wow, so basically we're talking about rewriting someone's genetic predisposition to heart disease.
Pretty much, yeah. And it's not just heart disease. They found similar reductions in risk for other big diseases, too. Like Alzheimer's, editing 10 genetic variants could take the risk from 5% down to less than 0.6%.
So someone who, might have been likely to develop Alzheimer's later in life could potentially, dodge that bullet.
Exactly. And for schizophrenia, the potential reduction is even crazier. They're saying editing 10 variants could bring the risk down from 1% to, again, 0.1%.
It's kind of hard to wrap your head around the impact that could have on public health if this actually becomes, a real thing.
It's definitely exciting to think about, but we have to remember, these are just theoretical estimates. It's all based on models. There's a lot more research that needs to be done before we can say for sure that HPE can do all this.
Right, of course. But it's still, pretty amazing to imagine a future where these diseases, these really serious diseases, become so much less common.
I know, right? It's a pretty wild thought. And they looked at type 2 diabetes, too. They estimated that editing 10 genetic loci could bring the lifetime risk down from 10% to just 0.2%.
So potentially we're talking about a future where people are just way less likely to get these chronic diseases that affect so many people today.
Exactly. And you know what Titus said? He said the crazy thing is, this isn't just some far-off fantasy. The basic technology, the foundation, is being developed right now.
So help me understand this. How close are we to actually seeing these benefits in real life?
Well, we already have CRISPR, right? And they're using CRISPR in clinical trials for somatic gene editing. That's where they edit genes in non-reproductive cells. So the changes don't get passed down to kids, but the fact that they're making progress with that is a really good sign for heritable gene editing.
Okay, so things are moving fast. But, earlier we were talking about all those ethical concerns. Does the progress with somatic gene editing, does that help address any of those issues?
It definitely gives us some insights. The more we learn about how gene editing works in somatic cells, the more we understand about the safety and how well it works. And that knowledge, we can use that for heritable gene editing. But even so, the ethical stuff, it's just way more complicated when we're talking about changes that can be passed down.
Because then it's not just about the person being edited, it's about their kids, their grandkids, right? It affects so many people down the line.
That's exactly it. And that's why the Nature paper is so big on proceeding carefully. They say we have to address those ethical concerns head on.
So let's talk about those ethical concerns. Can you walk me through some of the key issues that the Nature paper brought up?
Yeah, definitely. So one of the big ones, and we talked about this before, is safety and precision. When we start doing large-scale editing where we're targeting multiple genes at once, well, the risk of unintended edits goes up, those off-target effects.
Right, like you were saying before, it's like accidentally changing the wrong word in a document.
Right.
And it's especially scary when it comes to heritable changes because those mistakes, they get passed down forever.
It's true. And even what seems like a tiny unintended edit could end up having big consequences, especially if it becomes heritable. That's why the Nature paper is so insistent about the need for more research. We need to make these editing techniques more precise, more predictable. But right now, we just can't guarantee that HPE will be totally safe, especially not when we're making multiple edits.
It's kind of a sobering thought, isn't it? Even with all this amazing technology, there are still risks.
And the risks are just bigger when we're dealing with heritable changes. We're not just talking about one person's health, it's their children, their grandchildren, and so on. It's a lot of responsibility.
I see what you mean. So what about the cost? We talked about that before, too. The Nature paper mentioned that as a concern, right?
Yeah, they brought up cost and accessibility as a major ethical issue. Like we said, early HPC technology is going to be really expensive, and that could easily create a situation where only wealthy people can benefit from it.
And that would just make existing inequalities even worse. It's like the rich get to edit out disease risk, and everyone else is just stuck with whatever genes they inherited.
Exactly. That's why the Nature paper is so focused on the ethical implications of cost and accessibility. We have to find ways to make sure that HPE is available to everyone, not just people with a lot of money.
That seems like a really tough challenge. How do we prevent HBE from becoming like just another way to divide the haves and the have-nots?
Well, it's going to take a lot of effort from a lot of different people. Scientists, policymakers, ethicists, and the public, too. We need to keep investing in research, make HPE more affordable and more efficient. But we also need to come up with policies and regulations that promote equal access. That might mean things like government subsidies, insurance coverage, or even public funding. We need to make sure that everyone has the chance to benefit from HPE if they want to.
Okay, that all makes sense. But there's also the issue of public perception. People tend to be a little bit, I don't know, wary of new technologies, especially when it comes to messing with DNA.
For sure. And the Nature paper, they talk about how important it is to involve the public and communicate openly. The more we understand about HPE, the better we'll be at making decisions about how to use it.
And Titus was big on that, too. He was basically saying, hey, everybody, get informed, be part of the conversation. So are there any other big concerns that the Nature paper highlighted?
Yeah, they talked about the whole question of ethical boundaries, which is, a really tricky one. Like, if we can edit genes to prevent diseases, where do we draw the line? What's to stop us from using the same technology to enhance traits, like, make people smarter or more athletic?
Yeah, that's where it gets really complicated. It makes you think about, like, what does it even mean to be human? Should we be using technology to improve on nature? I don't know.
It's a really deep conversation, and it's probably going to keep going for a long time, especially as this technology keeps developing. But it's a conversation we need to have, and we need to think about the consequences carefully.
It feels like we're really just scratching the surface here. This is like a huge topic. Fascinating, but also a little bit overwhelming.
I agree. It's something that requires a lot of thought, a lot of debate, and a real commitment to doing things ethically as we move forward.
Okay, well, I think that's a good place to stop for now. We've covered a lot of ground in this deep dive into heritable polygenic editing, but there's still more to explore. Okay, so here we are, back for the final part of our deep dive into heritable polygenic editing. It's been like a wild ride.
Yeah, we've definitely covered a lot of ground.
It's pretty mind-blowing to think that we might actually be able to rewrite, the genetic code,
Yeah.
right? Prevent diseases that have been around forever.
It is pretty amazing, but we have to remember, all this power, it comes with responsibility. We have to really think about the consequences. All of them, the intended ones and the unintended ones.
So as we wrap things up here, what are the big takeaways? What do you want our listener to, walk away with?
Well, I think the main thing is that HPE, it's a field that's moving really, really fast.
Oh.
And it has the potential to completely change healthcare, like totally revolutionize it. The research is just exploding, and the possibilities are, well, they're pretty much endless at this point.
It's exciting to imagine, right? Like a future where diseases like heart disease, Alzheimer's, schizophrenia, they're just way less common.
Absolutely. But we can't forget that we're still in the early stages here. We've got a lot to figure out, especially when it comes to safety and precision.
And all those ethical considerations we talked about.
Yeah.
We can't just ignore those. We have to make sure that if HPE happens, that it's used responsibly and that everyone benefits, not just a select few.
Exactly. Titus, in his newsletter, he was really emphasizing that. He's all about public engagement. He says the more we know as a society, the better decisions we'll make about HPE. We all need to be part of the conversation.
And the Nature paper agreed with that, right?
Mm.
They were calling for a really thoughtful approach where everyone's included in the decision-making process. They're saying the choices we make now about HPE, they're going to have a huge impact down the line, for generations to come.
It's true. This isn't just about the science. It's about, our values. What kind of future do we want? How do we want to shape, human health and well-being? Those are big questions.
It's a good reminder that technology, it's a tool, and it can be used for good or for bad. It all depends on us.
Yeah.
We have to use it wisely.
I agree. And actually, that brings up something that the Nature paper posed in their conclusion. It's a really thought-provoking question, and I think it's one that we all need to consider.
Okay, I'm listening.
So they asked, if HPE becomes safe and affordable, would you consider it for your future children?
Wow, that is a big question. It really makes you think.
It does, right. And there's no easy answer. It's a really personal decision. And it's going to involve weighing a lot of factors, the potential benefits, the risks, the ethical considerations. It's a lot.
Yeah, it really makes you think about what would be most important to you. Is it about preventing specific diseases?
Mm-hmm.
Or is it more about enhancing certain traits? Where do we even draw the line?
It's tough. Those are questions that ultimately each person has to answer for themselves. But I think the important thing is to have those conversations openly and honestly within our families, with our friends, and as a society.
Yeah.
That's how we figure this out together.
I think that's a perfect place to end our deep dive. Heritable polygenic editing, it's a powerful tool. And it can change everything about healthcare. But it's up to us to use it responsibly, ethically. We have to be the ones to make sure that happens.
I couldn't agree more. We have to stay informed, stay engaged, and keep thinking about the long-term consequences of the choices we make today. Because the future, it really is in our hands.
That's it for this deep dive, everyone. Thanks for joining us. And until next time, keep exploring, keep questioning, and keep learning.